Hey everyone, welcome back to the Basic Aeronautical Knowledge series. Today, we're talking about time. Timekeeping is essential for navigation, flight planning, and global communication. In aviation, we don't just look at the local clock, we use a UTS to coordinate flights worldwide. In this video, we'll break down how time relates to longitude, the importance of time zones, local mean time, and how pilots use Coordinated Universal Time, UTC, for safe and accurate flight operations. Let's get into it. To understand time, we need to cover a few key definitions. Let's break them down. Universal Coordinated Time, or UCT, is the standard time used in aviation worldwide. It is based on the prime meridian in Greenwich, England, and is sometimes referred to as Zulu time. Pilots and air traffic controllers use UTC to ensure global coordination and avoid confusion caused by different local time zones. Local mean time, or LMT, is a method of timekeeping based on the position of the sun in the sky at a specific location. Historically, noon was defined as the moment the sun reached its highest point in the sky at that longitude. However, because every location had a slightly different LMT, it became impractical, leading to the adoption of time zones. Time zones divide the world into regions where the same standard time is observed. Each time zone represents a difference of 1 hour for every 15 degrees of longitude, east or west of UTC. This system ensures a standardized approach to timekeeping across different regions. Understanding these concepts is essential for flight planning, scheduling, and ensuring accurate communication across different locations. Next, we'll explore how longitude affects time and why pilots rely on UTC for accuracy. The Earth is divided into 360 degrees of longitude, with the prime meridian at 0 degrees located in Greenwich, England. This is the starting point for measuring longitude east or west. The Earth rotates 360 degrees in 24 hours, meaning it moves 15 degrees of longitude per hour. This movement is what creates our time zones. For every 15 degrees east of the prime meridian, the local time is 1 hour ahead of UTC. For every 15 degrees west, the local time is 1 hour behind UTC. Understanding longitude is key to grasping how time zones are structured and why pilots rely on a global standard time to stay coordinated. Next, we'll look at how this connects to Universal Coordinated Time, or UCT. Now we know that timekeeping needs to be standardized. We need to understand Universal Coordinated Time, or UCT. UTC is the global time standard used in aviation to ensure consistency worldwide. It is based on the prime meridian at 0 degrees longitude and remains constant year-round, meaning it does not change for daylight savings or local time adjustments. By using UTC, aviation professionals avoid confusion when operating across multiple time zones, making flight planning and communication more efficient and reliable. Before time zones were introduced, people used local mean time, or LMT, to determine the time of day based on the position of the sun. LMT is calculated using the sun's highest point in the sky at a specific longitude. At noon LMT, the sun is directly overhead at that location. Since the Earth rotates 15 degrees per hour, every longitude has a slightly different time. This method worked well for individual towns, but it caused confusion as travel and communication expanded, leading to the adoption of standardized time zones. How is local mean time calculated? Every 15 degrees of longitude represents a 1 hour difference. Every 1 degree of longitude equals a 4-minute difference from Universal Coordinated Time, UCT. Understanding LMT helps us see why time zones were necessary for global consistency. Up next, we'll explore how time zones work and their importance in aviation. To keep timekeeping consistent worldwide, the Earth is divided into time zones. Time zones are regions of the Earth where the same standard time is used. They were introduced to standardize timekeeping and avoid the confusion caused by local mean time, LMT, which varied by longitude. The Earth is divided into 24 time zones, each covering roughly 15 degrees of longitude. Since the Earth rotates 360 degrees in 24 hours, this system ensures a logical progression of time as you move east or west. Time zones are based on Universal Coordinated Time, UCT, which is set at 0 degrees longitude, the prime meridian in Greenwich, England. Each time zone is then expressed as a UTC offset, such as UTC plus 10 for Sydney or UTC minus 5 for New York. We use group time formats to make communication clear and consistent. These formats appear in flight plans, weather reports, and operational messages. Now let's break them down so you can read them easily. Imagine the time is 9 a.m. on March 22nd, 2023. This can be written in several ways: 2023-03-2209-00. This format includes the year, month, date, and time. 2303-2209-00. This version shortens the year to the last two digits, followed by the month, date, and time. 032-209-00. This removes the year, leaving just the month, date, and time. 220900, like the simplest version, showing just the date and time. Time conversion is an essential skill in aviation, ensuring pilots, air traffic controllers, and flight planners stay synchronized across different time zones. Let's convert the given Coordinated Universal Time, UTC, to Australian Eastern Standard Time, AEST. We have 310123Z, which breaks down as date, 31st hour, 01 minute, 23. Using the Ursa excerpt for Archerfield in Queensland, we see that the airport operates in UTC plus 10 AEST. This means we need to add 10 hours to the given UTC time. This step ensures we reference the correct time zone for our location. In the next step, we'll apply the conversion. All right, now that we have identified the correct time zone, let's apply the conversion. We start with 310123 Zulu, which represents 31st, which is the date, and 0123 UTC. As the time from the Ursa excerpt, we know that Archerfield is in UTC plus 10. To convert, we simply add 10 hours to the UTC time. 123 plus 10 hours equals 11:23 Australian Eastern Standard Time. So the final local time in Australian Eastern Standard Time is 31st at 11:23. This conversion method ensures that pilots always use the correct local time for flight planning and operations. Right, now let's go through another example of converting time from UTC to Australian Eastern Standard Time. But this time, the conversion rolls into the next day. We start with 301815 Zulu, which represents 30th being the date 1815 UTC, being the time we apply UTC plus 10 for Australian Eastern Standard Time. 18 plus 10 equals 28 hours. Since 28 hours exceeds a 24-hour cycle, we need to add 1 day and subtract 24 from 28, giving us 4 hours. Our final local time in Australian Eastern Standard Time is 31st at 4:15 Australian Eastern Standard Time. Right? The definition of night is not just about sunset and sunrise. It's specifically defined in the AIP under Gen 2.7 night, begins at the end of the evening, civil twilight, and ends at the beginning of the morning civil twilight. First light is considered the start of civil twilight, while last light marks the end. The terms sunrise and sunset are not used when determining daylight operating times for VFR pilots. For VFR operations, this is critical to understand, as planning must align with official daylight operating limits rather than just sunrise and sunset times. Knowing the exact times for first and last light is essential for VFR pilots. Instead of using sunrise and sunset, we rely on civil twilight. Civil twilight occurs when the sun is 6 degrees below the celestial horizon. First light marks the beginning of morning civil twilight, while last light marks the end of evening civil twilight. And these times are crucial for determining daylight flying hours and ensuring compliance with VFR regulations, knowing that you need to be planned to be landed 10 minutes before last night. You will learn how to calculate these times as part of your studies, ensuring you always plan your flights safely and within legal limits. Thanks for watching this episode of the BAK series. If you're just starting your aviation journey, make sure you subscribe so you don't miss out on more essential lessons to help you ace your flight training, and check out teamaviation.com.au for more resources. Hit that like button if you found this useful, and leave a comment below with what you want to learn next. See you in the next video.